Hello everyone, welcome back to our data structures and algorithm series. So the question which we'll be solving today is kth largest element in an array. So we have given an array and we have to find the kth largest element. Fine. For example, in this case, the array is 3, 2, 1, 5, 6, 4, and the largest element is 6, and the second largest is 5. So we have to return 5. In this case, the largest element is 6, second largest is 5, third largest is also 5, and fourth largest is 4. So we have to return 4 because we want the fourth largest element. And one thing to notice here is we have to solve it without using sorting. Now, what's the time complexity of sorting algorithm? It is n log n, which means we can't solve it in n log n, right? Or we can simply say we can't sort it, or we can also say we can't solve it in n log n, right? So how will we solve this? Let's take an example. Let's take this example 3, 2, 1, 5, 6, 4. So we have 3, 2, 1, 5, 6, 4. First, let's try to solve it with the use of sorting. So if you sort this array, what will it become? It will become 1, 2, 3, 4, 5, and 6. And once you have sorted the array, you have to return the second largest, so you can just simply return the second element from the last, right? Which is 5. But what will be the time complexity in this case? We are sorting the array, so it will be n log n, right? So if you sort the array, the time complexity which we'll use is n log n, but it's clearly written we can't sort, which means n log n time complexity is not possible. Now, even if you try something else, like you'll map the element, you'll use set and all this thing, it will still end up using n log n because to insert in a set, it will take log n, right? So even in map, it will take log n. So you will, in the end, whatever you will do, you'll end up using n log n. And similarly in this case too. In this case, I have sorted the array, so it taken an extra log n. So the overall time complexity is still n log n. Fine. So what's the better than n log n? It's n. Like n is better than n log n. That's for sure. But there is one more time complexity in between. In this case only, which is n log of k. Now we can try to solve it in big O of n, but like in that case we'll have to use some modification of quicksort, but in that case the worst case will be n square, right? So we won't be using that because in the end the worst case will still be big of n square. We will always try to look for the worst case time complexity here. So if you use that modification of quicksort, you'll still be using n square. So we won't be using that. So you can't solve this in big O of n. Well, like you can't solve this question in big O of n in worst case time complexity because you have given an unsorted array and you have to find the second largest. So there is no way you can do it in big O of n. You will have to do some modifications, right? So the worst case time complexity can never be big O of n, and we can't use big O of n log n. So what's better than big O of n log n but not better than like n? What's in between? It's n log k. Like n log k, time complexity of n log k is less than this time complexity of n log n because k is always smaller than the number of elements. That's what given here. K is less than num's length. So n log k is a better time complexity than n log n. Now, so we'll try to solve it in n log k. So how will you solve this in n log k? See, this is a question of second largest, second smallest. So whenever we see questions like this, we'll always try to use a priority queue. So we'll solve this using priority queue. So let's try to solve it. So we have given it 3, 2, 1, 5, 6, 4. Let's write it again. 3, 2, 1, 5, 6, 4. And my k is 2. Now what I'll do, since I want the second largest, I'll use a min heap. Right, this is my priority queue and like it's a min heap. What I'll do, I'll first push two elements, like the first two elements, which is 3 and 2. Since it's a min heap, it will at the top it will be storing 2, right? Now what I'll do, I'll just check is my 1. What is at my top priority queue? 2. Now I know for sure that this is the smallest element in my priority queue because this is a min heap, it will always store the smallest at the top. So if I get any element smaller than these 2, is there any use of pushing it in my queue? Like this 1 is smaller than 2. Is there any use of pushing this in my queue? Why? Because it's smaller than the smallest element. So this can never be my second largest element, right? So I'll not push in my priority queue. Now next I'll move to 5. Now my 5 is actually greater than 2. right? 5 is greater than 2, which means 5 can be my second smallest. So what I'll do, I'll just pop this 2 and I'll push 5, right? So now my priority queue contains 3 and 5. Now I have moved to 6. Now what's that? What will be at the top of priority queue? It will be 3 because it's a priority queue. It will store the minimum at the top, which is 3. Now 6 is greater than 3, which means 6 can also be my second largest. So what I'll do, I'll just pop this 3 and I'll push 6, right? Now what will be at the top of my priority queue? It will be 5. Now I've moved to 4, right? Now is 4 greater than 5? No, it's not. So I'll not push. So iteration is over. Now what is remained in my priority queue? It's 5 at the top and 6 since it's a mini. So what's the second largest element? It's obviously the whatever is present in the top of the priority queue. So that's how we'll solve it. See, we have solved it in n log of k. Why n log of k? Because big of n for iterating and log k here, not log n. Because at max, your priority queue will always contain k elements. Like in this case, at max, it had always 2 elements, right? Initially, you push 2 elements and then you always pop the element before pushing. So at max, you'll always have k elements in your priority queue, right? So the time complexity here is n log k, which is better than n log of n, right? So this is how you will solve it. It's n log k. So let's look at the code. So what it's the same thing which I explained here. First I made a priority queue, which is a min heap, right? Then I first pushed the first k elements, which is I equal to 0 to I less than k. First I push the, in like, let's take this example. First I push the first two elements, right, which is 3 and 2. I can just write it here, right? First I pushed the first two elements. Then once I push the first two elements, I'll run a loop from k to last element, like, because I have already pushed the first two elements, so there is no need to check. Then I ran a loop from k to the last element, from I equal to k to I less than n. Then at every index I checked, is my nums of I greater than whatever is at the top of my priority queue? Is my nums of I, which is this first, is greater than whatever is my top of my priority queue? If it is greater, for example, this will not be pushed. 5. 5 is greater than 2. So just pop the element, because now I have got something better. So pop the element and push the new element, right? So whenever I get a greater element, I'm just popping my top, popping the smallest one, and I'm pushing the greater one, right? Once this is over, I know my priority queue will contain k elements, and the topmost element, like in this case my priority queue will contain in then 5 and 6, and my topmost element will be the second largest. And if largest, you need largest, it will be at the bottom of the priority queue. And if you need the kth largest, it will be at the top of the priority queue. In this case you need second largest, so it will be at the top, right? So in the end you will return pq.top. Now if you run this code, everything will run fine. Like I have also added 2 extra test cases, so everything is running fine, right? So we have reduced the time complexity from n log n to n log of k, and this is the best worst case time complexity in this question. Yeah, you can do it in big of n, but in that case the worst case will still be big of n square. So the best worst case time complexity is big of n log k. So we have reduced it from big of n log n to n log k, and that's what's been asked in the question, because we can't sort it, which means we can't use n log n. Fine. So this was all about this question. If you liked the video, please do subscribe to our channel, and I'll meet you in the next one. Thank you.